So, considering the constraint that I have circled, you'll be seeing that this particular constraint do not fit into the standard form. Here we have a negative sign in the RHS, so we'll have to convert this into a standard form, and then we can try to solve it. Otherwise, if you see all the constraints and the objective function satisfy the criteria, but except this particular constraint. So let's particularly make this into the standard format. So standard form of the given problem, it can be written as minimize z is equal to x1 minus 3x2 plus thrice of x3, right? And subject to 3x1 minus x2 plus twice x3 less than or equal to 7. Here how we are going to convert it? We are going to multiply both sides by minus sign. So minus 2x1 minus 4x2, right? So again the inequality sign will also change. It will be less than or equal to, and here we can write it as 12, right? Third constraint is okay. There is no problem in having negative sign at the LHS side. So minus 4x1 plus 3x2 plus 8x3 less than or equal to 10. And lastly we have x1, x2, x3 greater than or equal to greater than or equal to 0. So now that we have got the standard form of the given problem, what we can do is we can frame the simplex problem, right? The simplex problem can be framed by the regular method that we have been following. So what we can do is no, we have to just consider the slack variables. So the slack variables can be considered in the same way that of the maximization problem, right? So minus x1 minus 3x2 plus thrice x3 are all the objective function, and we have subject to 3x1 minus x2 plus twice x3 plus s1 is equal to 7. Here it is minus 2x1 minus 4x2 plus 0x3 plus s2 is equal to 12. And nextly minus 4x1 plus thrice x2 plus 8x3 plus s3 is equal to 10, right? So similarly, we can take cognizance of our slack variables in the objective function. It will be 0 s1 plus 0 s2 plus 0 s3, right? So it is not visible, plus 0 s3, right? And no, we can write x1 comma x2 comma x3 s1 comma s2 comma s3 greater than or equal to 0, right? So this is how the constraints of the can be framed, constraint can be framed, and the objective function can be framed in the simplex problem, right? So now that we have understood this, let's frame out the simplex table. So I'll be repeating, or I'll be writing this simplex problem statements again, so that there is no uh, confusion while framing out the table. So it is minimize z is equal to x1 minus 3x2 plus thrice x3 plus 0 s1 plus 0 s2 plus 0 s3, subject to it is 3x1 minus x2 plus twice x3 plus s1 is equal to 7 minus 2x1 minus 4x2 plus 0 x3 plus s2 is equal to 12 minus 4x1 plus thrice x2 plus 8x3 plus s3 is equal to 10, x1 comma x2 comma x3 comma s1 comma s2 comma s3 greater than or equal to 0, right? So this is how this statement is. We can frame the initial simplex table now. In frame initial simplex table, right? So framing the initial simplex table is easy. What we'll be doing is and here it will be solution column. It will be x1, x2, x3. Oh, sorry. We have cj. We have basic variables x1. This is x2, x3, s1, s2, s3. This is 0, 0, 0, 0, 0, 0. X1 is 1 minus 3, and this is 3. Sorry. Right? So we have to write solution here. Right? This is CB. Right? And right. So this is no. This is now this is initial simplex table. So we can write the slack variables only s1, s2, s3. Coefficients are 0, 0, 0. No, then we can frame out the constraints in the form of this particular table. So here it will be 3, 3 minus 1, 2, 1, 0, 0, and solution is 7. Similarly, we can find out for minus 2, for second constraint, that is minus 2, minus 4, it is 0. Then you have 0, 1, 0, and it is 12. Next it is minus 4, 3, then it is 8, and here it is 0, 0, 1, and we have it here as 10. So the first step is to find out the ZJ values. So ZJ values can be found out. How you'll be doing? It will be 0 into 3 plus 0 into minus 2 plus 0 into minus 4. Right? So it will be 0 only. You have to repeat the same for all the columns. Here, if you do so, you'll be getting 0, 0, 0, 0 only. Here also you'll be getting 0. Right? The next step is to find out Cj minus Zj. Cj minus Zj. So 1 minus 0 is 1. Minus 3 minus 0 is minus 3. 3 minus 0 is 3. 0 minus 0 is 0. 0 minus 0 is 0. And 0 minus 0 is 0. Now, for minimization problem, all Cj minus Zj values should be greater than or equal to 0. This is very, very important. For maximization problem, we have already seen that all Cj minus Zj values should be less than or equal to 0. But here, all your Cj minus Zj values should be greater than or equal to 0. Right? So, what we can do is we can move ahead, and what we can do is we can check whether the optimality is received or not. So for that, if we check out, you get that all Cj minus Zj values are not greater than or equal to 0. Hence, iterate further. Now, key column, how you are going to identify? Key column will be the value of Cj minus Zj, which is greater value with negative sign. Right. So here we have, I'll be writing here. Select the max value with negative sign for identification of key column. right? So here there is only one single value, so we are going to select this, and here it will be our key column, right? So now that we have got key column, we can get the this key row as well. So here what will be the same? So 7 divided by minus 1, it will be minus 7. 12 divided by minus 4, it will be minus 3. And 10 divided by 3 is 10 by 3. Right? So the leaving variable, what is the criteria for the leaving variable? It should be, just a second. So key row, same criteria, right? Minimum non-negative value. So the same criteria we have also applied for maximization problem. So that also remains same for your minimization problem, right? So minimum non-negative value is to be considered, but the non-negative value is only one. So we'll be considering this as the leading variable, and this is nothing but your key row. Getting this right. So now let's move ahead and do the iteration one. So I'll be redrawing this table again to avoid any confusion. So CV 1, 2, 3, 4, 5, 6, 7. This is solution and this is for ratio. Right. So this one is can be done as CJ, basic variable. You have x1, x2, x3, s1, s2, s3, 0, 0, 0. You have it as 1 minus 3, 3. Then you have it as CP. Then you have it here as solution and ratio. So I'm just repeating the previous problem, the previous step only here. Right. So here we can write is that S1, S2 and S3. Previous step only. So I'll be making it fast. 2, 1, 0, 0. It will be minus 2, minus 4, 0, minus 4, 3, 8. Right, solution is 7, 12, 10, minus 7, minus 3. That is 10 by 3. So Cj, that is Zj, Cj minus Zj values. So it is 0, 0, 0, 0, 0, 0 and 0 that we earlier got is 1 minus 3, 3, 0, 0, 0 that we got. So this was our leaving variable and this was our entering variable. So this is our key column and this is our key row. Right. So let's start for the iteration. Iteration 1. Right. So for iteration 1, let's redraw this table. This is CV 1, 2, 3, 4, 5, 6, 7. Here you have solution, and if a ratio required, that will be again considered. As of now, we don't know the ratio column will be required or not. So CV, Cj basic variables x1, x2, x3, s1, s2, s3. It is 1 minus 3 and 3 here. So first row, second row, and we have third row. Right. So let's See what was our entering variable? Entering variable was x2 and the leaving variable was s3. So you will be writing s1, s2, and here you will be writing it as x2. The coefficients are 0, 0. And the coefficient of x2 is minus 3. So you will be writing it here as minus 3. Similarly now, firstly, we are going to concentrate on the key row, right? So when we are going to concentrate upon the key row, what we are going to do is 1.016. So this is your angle twist. Theta. Yeah, Swapnil is asking me in the chat box. So we have to select max value from Cj minus Zj for key column. So this is not this that particular step was for maximization problem. This is your minimization problem. So hence I have written it specifically, right? So that is for minimization. Minimization. For minimization problem, what we are going to do is key column select the max value with the negative sign. Right, so negative sign is to be considered. No, so hence we are considered. So it is a minimization problem, right? Okay, so I hope you all have understood this. So yeah, so we have to consider the key row now. So in key row, all the new values will be what? The previous value divided by key element, right? So here it will be minus 4 divided by 3. 3 by 3 is 1, right? Nextly, we have 8 divided by 3, that is 8 by 3. Nextly, we have 0 by 3, the value is 0. 0 by 3, the value is 0. And 1 by 3, yeah. Solution as well, it will be 10 divided by 3. Right, so I'm hoping that you have understood how the new values of the key row have been found out. Now for non-key rows, what we are going to do is we are going to go with the formula. So for example, now let's start with the s1 row, right? So for s1 row, what we can write, our new value will be according to the formula. So the first value is like new value minus the corresponding non-key the corresponding key row value. So corresponding key row value is your minus 4, right? The corresponding key column value is minus 1 divided by key element, that is your 3, right? So if you do the calculation, you'll be getting that 3 plus 4 by 3, and that particular value will be nothing but 5 by 3. Right. Similarly, you can proceed using this particular formula. Now, for your second case, it will be minus 1 minus, right? So the corresponding key column value is the same, that is minus 1. Corresponding key row value is 3 divided by 3. So 3 will get cancelled. Minus 1 plus 1 will be equal to 0. Okay. So similar thing you can particularly apply. There is no need of writing this particular thing, or if you want, I can write it for you for all the elements. Okay, I'll be writing somewhere. We'll make space, and I'll be writing somewhere. Right. So the third will be right. So the third can be written as 2 minus, right? 2 minus the corresponding key column value is minus 1. Key row value is 8 divided by 3. So if you solve this particular thing, you'll be getting the value as 14 by 3. So you'll have to use the calculator to solve this. Huh? Don't do it on your own, right? So this is not visible. I'll be writing somewhere again. So yeah, okay. 2 minus 1 into 8 by 3. So this value will be nothing but it will be 14 by 3. Similarly, for the next step, we can write it as 1 minus 1 into 0 divided by 3. So the value will be what? It will be 1 only. Right. Similarly, for the next value, we can write it as 0 minus 0 into minus 1 divided by 3. The value will be 0 only. Similarly, we can write for the next thing as 0 minus 1 into minus 1 divided by 3, and the value will be 1 by 3. Similarly, proceeding ahead for the solution, we can write it as minus 7. For the solution, we can write it as 7 minus minus 1 into 10 divided by 3. And if you do the calculation, the answer will be 31 by 3. Right? Similarly, for the S2 values, you can go ahead with S2 value. The first value is minus 2. So minus 2 minus, right? Minus 4 into 3 divided by 3. So 3 will get cancelled. Minus 2 plus okay, it will be minus 4 into 3 divided by, yeah. So according to me, the value is coming out to be minus 22 by 3. So let me just check out. So it is minus 2 minus 4 into minus 4. Sorry. Okay. Here it will be again minus 4. Corresponding here, I'll be writing it again, sorry. So this will be minus 2 into minus 2 minus 4 into minus 4 divided by 3, right? Okay, so the value will be coming out to be minus 22 by 3. Nextly, we can write it as minus 4. I'll be writing it somewhere. It will be minus 4 minus 4 into 3 divided by 3, and the answer will be 0. So 3 will get cancelled. Minus 4 plus 4 will be 0. Nextly, we can write it as 0 minus 8 minus 4 into 8 divided by 3, and that particular value will be, right, so it will be 32 by 3. Nextly, we can write it for the next. It is 0 minus, right? So it will be 0 minus 0 into minus 4 divided by 3. It will be, the answer will remain 0 only. So you can do it for the other things. Your answer will come out to be like this. Right, so now you have to find out the zj value, right? So zj value will be what? It is 0 into 5 by 3 plus 0 into minus 22 by 3 plus minus 3 into minus 4 by 3. So no, if you do so, but 3 will get cancelled, minus sign will get converted into positive sign, the answer will be 4. Here again, 0 into 0 plus 0 into 0 plus minus 3 into 1, so the answer will be minus 3. Similarly, here the answer will be minus 8, it will be 0 0. Here the my answer will be minus 1. Here again the answer will be minus 10. Again calculating Cj minus Zj, 1 minus 4 is minus 3. 3 minus 3 plus 3 will be 0. 3 plus 8 will be equal to 11. It is 0 minus 0 is 0, 0 minus 0 is 0. 0 minus minus 1 is 1. So if you check all the all Cj minus Zj values are not equal to or not greater than or equal to 0. You have this minus 3 sign here. Because of that, the optimal solution is not reached, and you will have to iterate further, right? So I won't be writing that particular statement. Right, so your minus 3 is the maximum value with a negative sign. So this particularly will be your what? It will be your key column, right? And if you have to find out the ratio, so here the first ratio will be 31 by 3 divided by 5 by 3. It would be 31 divided by 5, right? Similarly, 76 by 3 divided by minus 22 by 3 will be minus 38 by 11. It will be 10 by 3 divided by minus 1 by 3 will be equal to minus 5 by 2, right? So this is how the ratio value is to be, ratio value has been calculated. Now what is, how we are allowed to find out the key row? Key row will be found out by considering the lowest non-negative ratio value. So there is only one non-negative value. So hence it will be, this will be your leading variable, and this will be your what? This will be your key row, right? So to avoid confusion, I'll be redrawing it, and then we'll be doing our iteration 2. Right, let me draw the table again for you. So iteration 1 table, right? Iteration 1 table we are redrawing. So CV 1, 2, 3, 4, 5, 6, and 7. So you have solution as well as ratio column. Right, so we have this as CG, basic variable x1, x2, x3, s1, s2, s3, so 0, 0, 0. Here it is 1, minus 3, and 3. It is CB. Here it is solution, and here it is ratio. Right, so we have three variables that we have considered. The first variable that we had was s1, s2, and this is x2, right? So it is 0, 0, minus 3. So it is 5 by 3 here, it is minus 22 by 3, it is minus 4 by 3. Right, so it is 0, 0, 1, it is 14 by 3, it is 32 by 3, it is 8 by 3. It is 1, 0, 0, it is 0, 1, 0, it is 1 by 3, 4 by 3, and 1 by 3. It is 31 by 3, 76 by 3, 10 by 3. It is 31 by 5, minus 38 by 11, and it is minus 5 by 2. Right? So we had ZJ values, CJ minus ZJ values. So it is 4, minus 3, minus 8, 0, 0, minus 1, and it was minus 10, and it was minus 3, then it is 0, it is 11, 0, 0, and 1. And here we have selected this as key column, and we have selected this as key row, right? So why this happen? Because all Cj minus Zj values are not greater than or equal to 0, hence iterate further. So that we concluded previously. Now we are going to proceed with the iteration 2. Iteration 2, right? So here we have CV 1, 2, 3, 4, 5, 6, 7, solution, and if a ratio column will be needed, we will be adding it. Right. So as of now, it is Cj basic variables. So x1, x2, x3, s1, s2, s3. So it is 0, 0, 0, and we have 1, minus 3, 3. There it is solution, right? So 1, 2, and here we have it as 3. 1, 2, 3. Right, so it is S1. Okay, S1 is to be, it is going to leave, and X1 is going to get added. So it will be X1. We have S2 as it is, and we have X2. So S1 coefficient is 1, S2 coefficient is 0, and it is minus 3. Right, so let's move ahead For non-key, no, for key row, how the new value will come? It will be previous value divided by the key element. So 5 by 3 divided by 5 by 3 is 1. 0 divided by 5 by 3 is 0. Then we have 14 by 3 divided by 5, so it is 14 divided by 5, right? Nextly we have 1 divided by 5 by 3, that is nothing but 3 by 5. Nextly we have 0 divided by 5 by 3 as 0, and 1 by 3 divided by 5 by 3 is nothing but 1 by 5. Even for the solution, 31 by 5 divided by 5 by 3 will be ending us the answer as 31 by 5. Right. So now for the next value, what you can do is you can try it at home. I'll be just writing the values, and you can check if my values are right or wrong. And with that, even you can also practice to how to get a new value. So I got my values as 0, 0, 56 by 5. It is 22 by 5. Then it is 1, 14 by 5. 354 by 5. 354 by 5. Nextly, we have it as 0, 1, 32 by 5. Then we have 4 by 5. Then we have 0. Then we have it as 3 by 5 and 58 by 5. Right? So you can check my values, right? That if I've got it right or not, you can take screenshot of this particular thing and try completing this problem as well. So Cj minus Zj. So I've got it as 1 minus 3 minus 82 by 5 minus 82 by 5. Then I have minus. I'll be redrawing this particular table because it got somewhat distorted, so that at year end you shouldn't be getting confused regarding the values, right? So CV 1, 2, 3, 4, 5, 6, 7, and I have the solution, right? So it is solution Cj basic variables x1, x2, x3, s1, s2, s3, 0, 0, 0. It was 1 minus 3 and 3. It is and yeah. So I got my values. It was x1, s2, x3. 1, 0, minus 3. So it is 1, 0, 0, 0, 0, 1. And then we have 14 by 5. We have 156 by 5. Then we have 32 by 5. That is 3 by 5. That is 22 by 5. We have 4 by 5. 0, 1, 0, 1 by 5, 14 by 5, and 3 by 5. So 31 by 5, 354 by 5, and it is 58 by 5. Right? So all these were the values that were obtained. So you can find it out with the help of Zj and Cj minus Zj. So it is 1 minus 3 minus 82 by 5. Then we have minus 9 by 5, 0, minus 8 by 5, and minus 143 by 5. Here the answer I got was 0, 0, 97 by 5, 9 by 5, 0, and 8 by 5. So according to me, all Cj minus Zj values are greater than or equal to 0. Hence, the optimal solution was reached. Right? So this is the case with me. So if I have to write the final answer, my final answer is x1 is equal to 31 by 5, x2 is equal to 0, No, because x2 variable is absent. We have s2. x2 is not present and x3 is equal to 58 by 5. I got the value of z minimum as it is the minimization problem. The z minimum value is minus 143 by 5, and this particularly is the final answer that I got.